February 14, 2026. 3:40 a.m. 12 Ukrainian GUR operators, 8 kilometers behind Russian lines. One objective no one in Moscow believed possible. Capture a Tor-M2 air defense system. Intact. Operational, with its crew still breathing. 6 minutes later, it was done. And Russia's short-range air defense network, the system protecting its ground forces from Ukrainian drones across the entire front, had just handed Kyiv its own operating manual. I'm your host at Ukraine Signal, where we analyze the battles that change wars. And this operation didn't just change a battle. It changed how Ukraine fights every engagement that comes after it. Because when you capture the enemy's air defense computer, you don't just win one firefight. You win 1,000 firefights that haven't happened yet. This is the story of Operation Cipher, the unofficial name given by GUR planners to one of the most audacious special operations raids of the entire war. A mission built on signals intelligence, drone reconnaissance, and 12 men willing to walk through minefields in the dark for 2 consecutive nights to pull off what Russian commanders assumed was impossible. Let's break it down. To understand why Ukraine risked 12 of its best operators to capture a single vehicle, you need to understand what the Tor-M2 was doing near Kreminna, northern Luhansk Oblast, late January 2026. Ukrainian forces had been conducting a grinding offensive toward the outskirts of Kreminna since autumn 2025, pushing through the dense forests and ravines that define this part of the front. Progress was measured in hundreds of meters per week. Every Ukrainian advance depended on one thing above all else: drone reconnaissance. Without eyes in the sky, Ukrainian infantry moved blind into Russian defensive positions. Without real-time ISR feeds from reconnaissance UAVs, artillery couldn't adjust fire onto Russian trenches and strongpoints. Without the steady stream of Mavic and Autel feeds flowing into tablet screens at company command posts, every assault was a gamble. And since mid-January, those eyes had been going dark. Ukrainian drone operators working the Kreminna axis noticed a pattern. Reconnaissance UAVs launched from positions west of the Zherebets River were being destroyed at an alarming rate. Not by electronic warfare, not by small arms fire, by precision missile intercepts. The losses were surgical. A Mavic 3 flying at 400 meters altitude, 5 kilometers from the front line, would simply vanish from the feed. No warning, no jamming signature, just a clean cut to black. When recovery teams found wreckage, and they rarely did, the damage pattern was consistent. Fragmentation from a proximity-fused missile warhead detonating within meters of the airframe. Something was swatting Ukrainian drones out of the sky with terrifying efficiency. Ukrainian signals intelligence identified the culprit within days. A Tor-M2 short-range air defense system operating from a concealed position in a tree line approximately 8 kilometers behind the Russian front, northeast of Kreminna. The system's radar emissions were intermittent. It powered up, engaged, and shut down in cycles designed to minimize its exposure to Ukrainian counter-battery targeting. The Tor-M2 is no ordinary air defense platform. Manufactured by the Almaz-Antey Corporation, it represents one of Russia's most capable short-range systems. Each Tor-M2 combat vehicle carries 8-9 M338 missiles in vertical launch cells, capable of engaging targets at altitudes from 10 meters to 10,000 meters, at ranges up to 16 kilometers. The system's phased array radar can track 48 targets simultaneously and engage 4 of them at once. Reaction time from target detection to missile launch, 5 to 8 seconds. For Ukrainian drone operators, this was a nightmare. The Tor-M2 wasn't just destroying expensive reconnaissance platforms. It was creating a blind zone, a bubble of denied airspace roughly 32 kilometers in diameter where no Ukrainian UAV could operate safely. And that blind zone sat directly over the axis of advance toward Kreminna. Which weapon was deadlier against Ukrainian drones in this sector? The Tor-M2's missiles, Russian electronic warfare systems, or small arms fire? Comment below with your answer. Ukrainian brigade commanders on the Kreminna axis reported a measurable decline in operational effectiveness. Without drone feeds, artillery accuracy dropped. Without artillery accuracy, infantry assaults stalled. Without infantry pressure, Russian forces consolidated defensive positions. One Tor-M2, operated by a crew of 4, was single-handedly degrading an entire brigade's offensive capability. The obvious solution was destruction. Ukraine had options. A HIMARS strike with M31 GMLRS rockets, a loitering munition sortie. Even a concentrated FPV drone attack might overwhelm the system's defenses if enough platforms were committed simultaneously. But GUR intelligence analysts saw something more valuable than a destroyed Tor-M2. They saw an opportunity. Since the early months of the war, Western and Ukrainian intelligence had been working to understand the inner workings of Russia's integrated air defense network. Captured fragments of S-300 missiles had provided some data. Destroyed Panzer S-1 systems yielded partial circuit boards, but no one had ever captured a fully intact operational Tor-M2, complete with its radar processing unit, IFF transponder codes, engagement software, and missile guidance algorithms. The intelligence value was almost incalculable. A working Tor-M2's onboard computer contained the software that determined how the system classified targets, how it distinguished between a Ukrainian reconnaissance drone, a friendly Russian UAV, a bird, and electronic noise. It contained the IFF, identification, friend or foe, codes and protocols that the entire Russian air defense network used to prevent fratricide. It contained engagement algorithms that revealed the system's decision-making logic, which targets it prioritized, how it allocated missiles, what its tracking limitations were. If Ukraine could put that data on a table in front of Western electronic warfare specialists, the implications were staggering. Every Tor-M2 operating across the 1,000-kilometer front could potentially be degraded, confused, or defeated using countermeasures derived from its own software. Destruction would eliminate one system. Capture would compromise all of them. GUR planners began developing the operation in late January 2026. The first challenge was intelligence, knowing exactly where the Tor-M2 was, when it moved, and how it was defended. Signals intelligence provided the foundation. Ukrainian SIGINT stations monitored the Tor-M2's radar emissions continuously, building a pattern-of-life profile. The system operated from a primary position in a tree line running northeast to southwest, approximately 800 meters from a secondary road used for logistics resupply. It displaced to alternate positions periodically, but always returned to the primary site within 12 to 18 hours. Satellite imagery, supplemented by high-altitude Ukrainian reconnaissance drones operating at the extreme edge of the Tor-M2's engagement envelope, filled in the visual picture. The tree line offered concealment from above, with camouflage netting strung between the trunks. 2 support vehicles, a logistics truck, and a command variant of the BTR-80 were parked nearby. A network of shallow fighting positions surrounded the site, occupied by infantry providing local security. Stay with me, because what happens over the next 48 hours turns a 12-man special operations team into the most important intelligence asset Ukraine has deployed all winter. GUR analysts identified a critical vulnerability in the security rotation. The infantry platoon guarding the Tor-M2 site rotated every 48 hours. During the changeover, which typically occurred between 3 a.m. and 4:30 a.m., there was a period of confusion. Outgoing troops loading onto vehicles, incoming troops orienting to positions, reduced alertness from soldiers who had just completed a nighttime road march to the site. The changeover window was the seam in the armor. Operational planning intensified in early February. The 12-man team was selected from GUR's direct action units, operators with extensive experience in behind-the-lines missions. Every man on the team had conducted at least 3 deep penetration operations since 2024. They trained on a mock-up of the target site built at a rear training facility, rehearsing the assault until every movement was automatic. The route was the second critical challenge. 8 kilometers of Russian-controlled territory separated the nearest Ukrainian position from the Tor-M2 site. Between them lay minefields, both legacy and freshly laid, Russian observation posts, and at least 2 company-strength defensive positions. Ukrainian drone operators spent a week mapping a route through the obstacles. Flying at night, using thermal cameras, they identified gaps in the minefields, dead ground invisible to Russian observation posts, and timing windows when Russian sentries rotated or sheltered from the cold. The route data was compiled into a detailed overlay that the GUR team would follow on ruggedized tablets with GPS navigation. The infiltration plan called for 2 nights of movement. Night 1, cross the front line through a pre-coordinated gap in Ukrainian minefields, Advance 4 kilometers to a layup position in a ravine and go to ground before dawn. Night 2. Advance the remaining 4 kilometers to an assault position within 200 meters of the Tor-M2 site and wait for the guard changeover. Extraction was the most dangerous phase. Driving a captured vehicle, a tracked 17-ton air defense system, back through 8 kilometers of contested territory in the dark. GUR planners coordinated a pre-cleared corridor. Ukrainian artillery would suppress known Russian positions along the route. FPV drone teams would provide overwatch and engage any Russian quick reaction force, and a Ukrainian mechanized platoon would push forward to link up with the returning team at a designated handover point 3 kilometers from the front. The operation launched on the night of February 12, 2026. 12 operators crossed the front line at 10:15 p.m. through a gap in Ukrainian minefields southwest of the Zarabets River. Temperature, minus 11 degrees Celsius. Wind from the northeast at 8 kilometers per hour. Visibility under natural light, approximately 50 meters. Conditions were ideal. The team moved in 2 6-man elements separated by 40 meters, with the lead element navigating using the pre-mapped route on GPS-enabled tablets. Movement was painfully slow. Each step through potential minefield corridors required deliberate foot placement. The operators used lightweight mine detection probes in sections where the drone mapping had identified possible mining but couldn't confirm clearance. By 2:30 a.m. on February 13th, the team had covered 4 kilometers. They reached the designated layup position, a shallow ravine running perpendicular to the direction of advance, screened by scrub vegetation and fallen timber. The 12 men settled into the frozen ground, pulled thermal concealment blankets over their positions, and waited for daylight to pass. For 16 hours, they lay motionless. Russian logistics vehicles passed on a road 300 meters to the north. At one point, a Russian 2-man foot patrol walked within 150 meters of the ravine. The GUR operators controlled their breathing, kept their weapons tucked beneath thermal blankets to mask their heat signatures, and waited. Night fell on February 13th. At 8:45 p.m., the team began the second phase of infiltration. The remaining 4 kilometers were more dangerous. Russian defensive positions were denser here, and the team was now well within the zone of active patrolling. 2 hours into the movement, the lead element froze. A Russian observation post, not identified during the planning phase, sat on a slight rise 120 meters to the right of the planned route. Thermal optics revealed 2 soldiers, one scanning with night vision, the other operating a radio. The team leader made a decision in seconds: divert. The team swung 200 meters south, adding 30 minutes to the approach but avoiding the unplanned obstacle. No shots fired, no alerts triggered. By 2:50 a.m. on February 14th, all 12 operators were in their assault positions, 200 meters from the tree line. They could see the Tor-M2 through their thermal optics, its hull radiating heat from the diesel engine that powered the system's electronics. The camouflage netting draped above it, the shapes of soldiers moving between fighting positions. How many Russian soldiers guarded the Tor-M2 site in total, including the air defense crew? A. 18, B. 28, C. 34. Answer at the end of this video. The team waited. At 3:15 a.m., vehicle headlights appeared on the secondary road to the northeast. The incoming guard rotation. 2 trucks, a Ural 4320 and a COM-AS, carrying the replacement platoon. The outgoing troops began gathering equipment, loading packs onto the departing vehicles. For approximately 25 minutes, soldiers milled around the site in organized chaos, some shaking hands with their replacements, others orienting the new arrivals to positions. This was the window. At 3:40 a.m., the team leader initiated the assault. The first shots came from 2 GUR snipers positioned on the left flank, engaging the Russian soldiers closest to the Tor-M2 vehicle itself. Suppressed rifles. 2 targets dropped before anyone understood what was happening. Simultaneously, the 2 6-man assault elements advanced from the south and southwest, moving fast and low through the underbrush. Suppressed automatic weapons opened up on the fighting positions. The Russian security element, caught in the middle of a changeover, with some soldiers not yet in their assigned positions and others already packed to leave, reacted with confusion. Return fire was sporadic and uncoordinated. Some Russian soldiers fired blindly into the tree line to the south. Others dove into fighting positions. The 2 trucks on the road attempted to reverse, but the lead vehicle stalled when the driver panicked and killed the engine. The GUR operators worked with surgical precision. Each pair within the assault elements had pre-assigned sectors of fire and pre-identified targets from the rehearsals. The leftmost pair cleared fighting positions on the eastern perimeter. The center pair pushed directly toward the Tor-M2 vehicle. The right pair isolated the two trucks, pinning down soldiers attempting to dismount. Fragmentation grenades went into 3 fighting positions in rapid succession. The concussions shattered the cold air. Subscribe to Ukraine Signal if you want to understand how modern warfare actually works, because operations like this one are rewriting the rules of 21st century combat. Within 3 minutes, effective Russian resistance collapsed. The security element was a mix of casualties and soldiers who had dropped their weapons and were pressing themselves flat against the frozen earth. GUR operators moved through the position systematically, securing prisoners and clearing remaining threats. The Tor-M2 crew, 4 soldiers sheltering inside the vehicle when the assault began, presented a unique problem. The vehicle's armored hull provided protection against small arms fire. The crew could have buttoned up and attempted to drive away, but the GUR team had planned for this. 2 operators reached the vehicle within 90 seconds of the assault's initiation and placed charges on the hatches. Not breaching charges, but flashbangs with adhesive mounts that detonated directly against the hull. The concussive shock inside the armored compartment was disorienting. When a GUR operator pulled open the commander's hatch and pointed a weapon inside, shouting commands in Russian, the 4 crew members surrendered immediately. The entire firefight lasted 6 minutes. 14 Russian soldiers were killed, 8 were wounded, 12 were captured, including the 4-man Tor-M2 crew. GUR casualties: 1 operator with a fragmentation wound to the left forearm. Treated on site. Operational. The clock was now running. Russian forces would detect that communication with the Tor-M2 site had ceased. A quick reaction force would be dispatched. The team estimated they had between 20 and 35 minutes before a Russian QRF could reach the area. 2 GUR operators, both trained on Russian armored vehicle operation, climbed into the Tor-M2. The vehicle's diesel engine was already warm. 1 operator took the driver's position. The other sat in the commander's seat, monitoring the system's internal displays to ensure nothing was transmitting that could reveal their movement to Russian electronic surveillance. The 17-ton vehicle lurched forward, crashing through the camouflage netting and turning south toward the pre-cleared extraction corridor. Behind it, the remaining 10 operators organized the prisoners into a column, destroyed the 2 Russian trucks with thermite grenades to prevent pursuit, and began moving south on foot. The prisoners would slow them down, but leaving them unguarded risked a Russian soldier reaching a radio. The extraction corridor activated at 3:52 a.m. Ukrainian artillery. 155mm shells from PZH 2000 self-propelled howitzers, positioned 12 kilometers behind the front, began hammering pre-registered Russian positions along the extraction route. The barrage wasn't aimed at specific targets. It was suppressive, designed to keep Russian heads down and prevent any organized response to the sound of a tracked vehicle moving through their rear area. Simultaneously, 3 FPV drone teams launched from positions near the front line. 15 drones in total, each carrying fragmentation warheads, pushed into the airspace above the extraction corridor. Their mission: find and destroy any Russian vehicle attempting to intercept the Tor-M2. The captured vehicle moved at approximately 25 kilometers per hour over rough terrain, the maximum safe speed the GUR driver could manage in darkness with unfamiliar controls. The route followed farm tracks and field boundaries, avoiding the secondary road where Russian logistics traffic might be encountered. At 4:08 a.m., the first Russian response materialized. A BTR-82, a armored personnel carrier, part of a quick reaction force from a Russian company positioned 2 kilometers east, began moving west on an intercept course. Ukrainian drone operators detected it immediately on thermal cameras. If you believe tactics win wars, not just numbers, type Ukraine Signal in the comments, because this operation proves that 12 determined operators can achieve what a battalion could not. 2 FPV drones dove on the BTR-82A simultaneously. The first struck the engine compartment, detonating its fragmentation warhead against the thin upper armor. The vehicle slewed to a halt, smoke pouring from the engine bay. The second drone hit the turret, ensuring the 30mm autocannon couldn't engage. The BTR's crew dismounted and scattered into the darkness. A second Russian vehicle, a Tiger M armored car, appeared on the secondary road 5 minutes later, moving fast toward the Tor-M2's last known position. Another FPV drone caught it from behind, striking the rear axle. The vehicle rolled to a stop with a shattered drivetrain. The drone teams were performing exactly as planned, creating a moving bubble of protection around the captured Tor-M2 as it crawled toward friendly lines. At 4:23 a.m., the Tor-M2 reached the 3-kilometer mark. Ukrainian positions were close now. The mechanized platoon designated for the link-up, 3 Bradley M2A2 infantry fighting vehicles, pushed forward from their staging area and established a screen facing east. Their 25mm Bushmaster cannons and Tau missile launchers covering the approach routes any Russian counterattack would use. The Tor-M2 crossed into Ukrainian-controlled territory at 4:31 a.m., 51 minutes after the assault began. The GUR driver brought the vehicle to a halt behind a Ukrainian defensive berm, and the 2 operators climbed out to the sight of Ukrainian infantrymen staring in disbelief at a pristine Russian air defense system sitting in their lines. The foot element, 10 GUR operators and 12 Russian prisoners, arrived 47 minutes later, having moved at a slower pace through the extraction corridor. The wounded operator was evacuated by armored ambulance. The prisoners were transferred to Ukrainian military intelligence for interrogation. By sunrise on February 14th, the Tor-M2 was loaded onto a heavy equipment transporter and moving west, deeper into Ukrainian-controlled territory. Destination: a classified rear facility where Ukrainian and Western intelligence specialists were already assembling. The intelligence exploitation began within hours. The Tor-M2's onboard computer systems were the primary target. Ukrainian electronic warfare specialists, working alongside advisors from at least 2 NATO member states, began extracting and analyzing the system's software architecture. The first discovery was the IFF system. The Tor-M2's identification friend or foe transponder contained the current Russian military IFF codes, the encrypted signals that Russian aircraft and air defense systems use to identify friendly platforms and avoid engaging them. These codes are changed periodically, but the protocols, encryption methods, and code structure provided a template for predicting future iterations. Ukrainian electronic warfare units could potentially spoof Russian IFF signals, causing Russian air defense systems to misidentify Ukrainian drones as friendly platforms. The second treasure was the radar processing software. The Tor-M2's phased array radar uses sophisticated algorithms to filter targets from background clutter, to distinguish a small reconnaissance drone from a bird, a decoy, or atmospheric interference. Understanding these algorithms meant understanding the system's blind spots. Ukrainian engineers could design drone flight profiles, radar cross-section modifications, or electronic countermeasures specifically tuned to exploit weaknesses in the Tor-M2's target discrimination logic. The third revelation was the engagement prioritization software. When the Tor-M2 detects multiple targets simultaneously, its computer assigns priority based on a complex matrix of factors: target speed, altitude, radar cross-section, trajectory, and proximity. Knowing this matrix meant Ukrainian forces could design saturation attacks calibrated to overwhelm the system's decision-making, sending low-priority decoy targets to consume its attention while high-priority strike drones approached from angles the system was slower to process. What would NATO electronic warfare specialists have done differently with this intelligence? Comment your analysis below. The fourth discovery was perhaps the most operationally significant: the communication protocols linking the Tor-M2 to Russia's broader integrated air defense network. The system's data links revealed how targeting information flowed between radar stations, command posts, and individual air defense platforms. This network architecture data gave Ukrainian planners a map of the connections they could sever or corrupt to degrade Russian air defense coordination across entire sectors of the front. Within 3 weeks of the capture, Ukrainian electronic warfare units on the Kreminna axis reported measurable changes in Tor-M2 effectiveness. Specific countermeasures, the details of which remain classified, were deployed that reduced the kill probability of Tor-M2 engagements against Ukrainian reconnaissance drones. Ukrainian sources indicated that drone losses in the sector dropped by approximately 40% in the first 2 weeks after the new countermeasures were implemented. But the impact extended far beyond Kreminna. The Russian military operates an estimated 60 to 70 Tor-M2 systems across the front in Ukraine, Every single one of them runs fundamentally similar software. The vulnerabilities identified in the captured system's code apply, to varying degrees, across the entire fleet. Ukrainian electronic warfare specialists began developing and distributing countermeasure packages to units across the front, from Kherson in the south to Kupiansk in the north. Russia's response revealed the depth of the problem. Within days of realizing the Tor-M2 had been captured intact, information that likely reached Moscow through the interrogation reports of the captured crew, Russian air defense units received emergency orders to update IFF codes and modify operating procedures. But changing software across dozens of deployed systems in a combat zone is neither fast nor simple. Some units received updates within a week. Others were still operating with compromised protocols a month later. The Russian General Staff also ordered an investigation into the security failure that allowed the capture. The commander of the platoon responsible for guarding the Tor-M2 site was reportedly arrested. The practice of conducting guard changeovers during nighttime hours was suspended in the sector, replaced by daylight rotations, which, ironically, made the security elements more visible to Ukrainian drone surveillance. The operational security cascading effect was significant. Russian air defense crews across the front became more cautious, displacing more frequently, powering down radar systems for longer periods, and requesting additional security forces. All of these defensive reactions degraded the system's effectiveness. A Tor-M2 that displaces every few hours spends significant time offline during movement. A system that limits its radar emissions to reduce detection risk also limits its ability to protect ground forces from Ukrainian drones. One captured vehicle was achieving what hundreds of Ukrainian strikes could not, forcing the entire Russian short-range air defense network into a defensive, degraded posture. The GUR team that executed the operation was awarded state honors in a classified ceremony. The team leader, whose name remains undisclosed, reportedly received the Order of Bohdan Khmelnytsky, one of Ukraine's highest military decorations. The wounded operator returned to active duty within 3 weeks. The captured Tor-M2 crew provided valuable intelligence during interrogation. The system commander, a senior lieutenant with 4 years of service, described the air defense unit's operations in detail, including standard operating procedures, maintenance cycles, and the frequency of software and IFF code updates. This human intelligence complemented the technical data extracted from the vehicle's systems. Real tactics, real consequences, Ukraine signal. The broader lessons of Operation Cipher extend well beyond a single captured vehicle. This operation demonstrates several principles that are defining the character of the war in 2026. First, the integration of intelligence disciplines. The operation succeeded because signals intelligence, drone reconnaissance, satellite imagery, and human analysis were fused into a single operational picture. No single intelligence source provided enough information to plan the raid. Together, they created a level of situational awareness that made the impossible feasible. Second, the value of capture over destruction. Military thinking traditionally emphasizes destroying enemy capability. Ukraine's decision to risk a complex ground operation to capture the Tor-M2 intact rather than simply hitting it with a HIMARS volley reflects a sophisticated understanding of information warfare. The intelligence gained from one captured system is degrading dozens of identical systems across the front. Third, the decisive role of drones in enabling ground operations. FPV drone teams provided the close air support that made extraction possible. Without the drone screen suppressing Russian quick reaction forces, the captured Tor-M2 would never have reached friendly lines. Drones are no longer just strike weapons. They are the backbone of tactical maneuver. Fourth, the continuing importance of special operations forces. In an era dominated by drones, satellites, and precision munitions, 12 men on foot with rifles and grenades accomplished what no technology could do alone. They physically seized a piece of equipment that had to be taken intact. No missile, no drone, no electronic attack could have achieved that objective. Fifth, the asymmetry of intelligence warfare. Russia invested significant resources in deploying and protecting its Tor-M2 systems. Ukraine invested 12 operators and 2 nights of careful movement to compromise the entire fleet's effectiveness. The cost ratio is extraordinary. 12 men versus 60-plus air defense systems. The math does not favor Moscow. For the quiz answer, the total number of Russian soldiers at the Tor-M2 site during the changeover, including the incoming and outgoing security elements plus the 4-man air defense crew, was approximately 28. The correct answer is B. The outgoing platoon numbered roughly 12, the incoming platoon numbered roughly 12, and the 4-man Tor-M2 crew brought the total to 28. The GUR team was outnumbered more than 2-1, but surprise, speed, and precision eliminated the numerical disadvantage within minutes. Now, consider these questions. Was the decision to capture rather than destroy the Tor-M2 worth the risk? 12. GUR operators, some of Ukraine's most experienced special forces personnel, walked through minefields for 2 nights to reach the target. If the operation had failed, if the team had been detected, ambushed, or unable to start the vehicle, Ukraine would have lost irreplaceable human capital. Was the intelligence worth the gamble? Could Russia have prevented this capture? The guard changeover pattern was predictable. The site's location was revealed by its own radar emissions. The security element was a standard infantry platoon, not a specialized air defense protection unit. Were these failures of doctrine, training, or simply the inevitable friction of a force stretched across a 1,000-kilometer front? What would you have done differently, as the Ukrainian planner or as the Russian commander defending the site? Subscribe to Ukraine Signal, because we break down the battles that textbooks will study for decades. Real tactics, real consequences. And every week, we bring you the operations that are reshaping modern warfare from the ground up. The tree line northeast of Kreminna is quiet now. Russian forces abandoned the position within hours of the assault, pulling back to secondary defensive lines. The fighting positions where Russian soldiers slept and ate and watched the dark forest are empty. Shell casings litter the frozen ground. Tire tracks from the Tor-M2's departure cut deep ruts in the mud that have since frozen solid. But 8 kilometers to the west, in Ukrainian-held territory and far beyond it, in laboratories and intelligence centers across Europe, the data extracted from that captured vehicle continues to work. Every Ukrainian drone that flies a little higher, a little more confidently, above Russian positions near Kreminna or Kupiansk or Zaporizhia carries the ghost of that February night with it. Every Tor-M2 missile that misses its target, confused by countermeasures born from its own stolen software, is a reminder. Modern warfare punishes complacency without mercy. And on the night of February 14, 2026, 12 Ukrainian operators proved that the most dangerous weapon on the battlefield isn't a missile or a drone. It's information. Stay vigilant.